And the last one, when OH is replaced by nitrogen, so that is the amide. Okay, so these are 5 different functional groups. So best, I wrote this one based on their reactivity. Acyl chloride. See, this is the acyl chloride. Acyl chloride. And this is called anhydride. Anhydride. Okay. This is the thioester. And this is just ester. And this one is amide. Okay. So what is this one? The very first one is this acyl chloride is the most reactive. Then comes anhydride, then the thioester and ester and amide. So what is this reactivity? All this reactivity is based on nucleophilic acyl substitution. Suppose here if you have Y, see all these 5 structures, they are different in terms of Y. Here you have chloride, here this anhydride part, Sr, Or, and H2. Okay. So when you react this one with water, so what will happen? Y is a leaving group. Okay. So this is the general mechanism. Okay. O minus OH2 plus, okay, and Y. So this is deprotonation, and then the Y will leave. Okay, so what it will form? It will form acid. Okay, so if you react all this with water, you will come back to the acid. This is the parent compound. Okay, acid, and this is called hydrolysis. Hydrolysis. Okay, so best. So which one will react the fastest? Acyl chloride. Then we'll react the acyl anhydride. Then we'll react with thioester. Then the ester and amide is the least reactive. Okay. So in this series, amide is the least reactive. So this is the important need to remember. Okay. So based on the hydrolysis means reaction with water. So now I can see that you can make from acyl chloride to anhydride we can make, because anhydride is less reactive than the acyl chloride. If you take a nucleophile RCO minus Na, you can make this product. Here you see the nucleophile will come and chlorine will leave. Okay, and similarly, if you react the anhydride with an sulfur nucleophile, okay, it can react, this will leave, so you will get the thioester. This one, because it's more reactive, if you take oxygen nucleophile, it can react, sulfide can leave, so you'll get the ester product, and the ester you react with ammonia. Okay. So, but the reverse we cannot make is not the reverse reaction, because the ester is more, amide is less reactive than the ester. So the reverse reaction here you see, if you take this generally will not happen. Sorry, Here ORO minus, because amide is less reactive than uh, the amide is less reactive than the ester, so the reverse reaction is not favorable. Okay. In some exceptional cases it happens, but you guys need not to worry about this. So similarly, we see here thioester is less reactive than the chloride. So chlorine is more reactive. So we can directly react the S minus and you get the thioester. Okay. This chloride is very reactive and you can directly react with RO minus. It will form the product. Okay. Similarly, you can acyl chloride, it directly react with NH2, NH3, NH2 minus, it will form the product. Okay. So this is the reactivity pattern. And you see, so the point is most reactivity acyl chloride, then anhydride, then thioester and ester and amide. So you can come uphill to downhill, but not from downhill to uphill. So just the reactivity pattern, remember, okay? So it means now you see anhydride to amide. You can make directly anhydride to amide by reacting with NH3 or NH2 minus, NH3. Okay. Similarly, this anhydride to ester also you can make by reacting with RO minus nucleophile. So you can take any combination and we can do these functional group transformations. Okay. So this is a very key thing to remember, that acyl chloride is the most reactive, then anhydride, then thioester, then esters and amides. So in the last two lectures, we have seen the detailed reactions of esters and amides. Today, I gave you guys this brief idea and we will talk a few more reactions. Okay. First, we'll talk about the nomenclature. Okay. So first, the acyl chlorides. So how acyl chlorides are very important. See, this is called generally acyl chloride. This portion is acyl and then is chloride. Okay. And if it is aromatic, okay, then it is called benzoyl chloride. Benzoyl chloride. See, this is the benzyl. Remember that one carbon, it is a benzyl to CO benzoyl chloride. Okay. And if it is like aromatic, okay, sorry, cyclic but not aromatic, then we just say carbonyl chloride. They say carbonyl chloride. So this will be called cyclopentane carbonyl chloride. Okay, cyclopentane carbonyl chloride. That's how we name this one. So just remember the simple structures. Okay, this one, like this one. See, this acid is called oxalic acid. See, because these are derivatives. So if you convert that to COCl, okay, OH replaced by Cl. So oxalic acid So this is we call oxallyl, YL, okay? Ik, you remove ik with YL, oxalyl chloride. Okay. Similarly, this is acetic acid. See if you will have OH, acetic acid, and if you do this one, COCl, acetyl chloride, acetyl chloride. So we convert that acetic acid, see, acetic acid. So IC is removed, replaced by YL, acetyl chloride. And you guys know how can we make this one? The reagent always you see many times, thionyl chloride, okay? So see this, if you react with thionyl chloride, it will make, this is the preparation, okay? Let's come to the anhydrides, acid anhydrides. So first try to understand why do we say this acid anhydride, okay? See, if you have acetic acid, let's take the simple example, acetic acid or formic acid. So CH3COOH, okay? So two molecules you combine and remove water, okay? H from one molecule H and another molecule OH. So what will happen? So CH3 OOCOCH3, okay, plus H2O. So that's why it is called anhydride, means removal of water, hydride, anhydride, okay. So anhydride, see this is oxygen, this oxygen, and two carbonyls, these two carbonyls, and CH3. Okay, so this is they are called the acid anhydrides. Okay, so here what is the acid? Acetic acid. Okay, so this will be called acetic anhydride. Remove the acid and just anhydride, because you see both sides when they are symmetrical. Okay, so this reaction is generally such type of reaction happens when is heated at in anhydrous condition at very high temperature. Okay, very high temperature heating will make this one. When now suppose if you have, see the most reactive now is, there are different ways of making this one. So suppose if you take this one is acetyl chloride, and you take, I will write the mechanism as well. So everything will go side by side. So O minus, what is this one? Sodium benzoate. Okay. So see acid chloride is very reactive. It will go nucleophilic addition. So CH3 O minus and ClOCO, here the phenyl. So this will come back, chloride will leave. So you get this one here, COOCO and the phenyl ring. Okay. Plus, what will be the byproduct? See here, counterant sodium, and here Cl minus sodium chloride. So this is anhydride. Here you see, this is anhydride. COOCO anhydride. But this is called mixed anhydride, not symmetrical, it's a mix. See, this side CH3, this side you have phenyl. Okay, so how did this anhydride form? So this acetyl chloride and benzoyl chloride. Okay, so from the corresponding acid, parent acid, this will be named, and so acetyl and benzoyl, but you have to write in alphabetical order. So this will be called benzoyl, benzyl and acetic anhydride. Okay, so this is when the anhydride is mixed. When it is symmetrical, just you take the name and it will give just one of the structures, the acid will give you the name. Okay, so now you know the synthesis, and you know so anhydrides are made by the nucleophilic acyl substitution of chlorides with the salts. Okay, so third, so you guys can skip the nomenclature. Yeah, thioesters. So we'll not talk about thioesters, but I will suggest you guys to read in the book. These will come in biochemistry. Okay, so in biological reactions, mostly thioesters and phosphates. Let's talk about the ester nomenclature. Ester, OR. Okay. So ester nomenclature, see there are two parts here. One, that R prime, you need to name this one first. The R attached to the oxygen. Okay, it will be named first, and then the other portion will be considered as the derivative of an acid. Okay, same that acid. Instead of acid, oic acid, name ending will be O8. O8. Or if you will go to the alkane, you name this one. So R prime you name. Then the alkane, you remove alkane. You remove the E and add O8. So what it will be called? Alkanoate. Okay. So alkanoate. So see the example. I will go with the simplest example, COOCH3. Okay. So one carbon acid, what is that called? This one, OOH, this is called formic acid. Formic acid, okay, common name. Or systemic name, IUPAC name will be methanoic acid. Methanoic acid. Okay. So ester nomenclature, you will put first the name of this CH3. So this will be called methyl methanoate. Methanoate. Okay, that methane, see from this carbon, this methanoate came. Or if you will go in this way, just the general name, so this will be called methyl formate. Formate, see form, remove the E, remove the ic acid with 8. Okay. So in this, I will give you one more example. Let's say this one, CH3 CO. Let's say here you have CH3O CH3. Okay. So first you have to name this portion. So what is this one? This is isopropyl. Isopropyl. What is this one? 2 carbon. Okay. So 2 carbon, what is say ethane. So remove the E and add O8. Ethanoate. If you go 2 carbon acid as the parent compound, then it will be called acetic acid. So in that case it will be named as isopropyl acetate. Okay, remove the acetic acid, remove the ic acid and add ate, acetate. Okay, and let's say one aromatic, this one. So you have phenyl O and CH2, CH3. Okay, so you name this one first, so it will be called ethyl. And what is this one? From benzoic acid. So this will be called ethyl benzoate. Benzoate. Okay. So this is the ester nomenclature. Okay. And then the last one come to the amide nomenclature. Amide. So amide nomenclature is, so amide functional group CON, this one. Okay. So here R group, so N you can have hydrogens, or these hydrogens you can be replaced by carbons as well. So simple nomenclature for this IUPAC. What you do is also considered as the parent compound alkane. Remove E and add amide. Just this one simple. So what will be the compound will be called alkanamide. Okay. So let us see this one. If you have just this one, CON, just only one carbon alkane is methane. So this will be called methanamide. And one carbon acid is called formic acid. Okay. So formic acid. So remove E, and in that case, for general nomenclature, add remove ic acid and add amide. So this will be called generally formamide. Okay, from formic acid to formamide. Similarly, if you have this one, 2 carbons, so this will be called ethanamide, or acetamide. Okay, and then this see this exam. Now if you have other substituents here, Okay, hydrogens replaced by with the carbon, then those things you have to name first. Okay, like this one is one of the most widely used solvent to dissolve different organic compounds. 2 hydrogen replaced by 2 methyl groups. So here 2 methyl groups N, on the N you have methyl and 2 methyl. So you have to tell 2 times N. N dimethyl. So what is this one carbon? See this one here, methanamide, or generally it is called formamide. Formamide. N dimethyl formamide. In short, this is called DMF. Okay, and it's a widely used solvent and reagent as a reagent as well. And this is a polar aprotic solvent. Okay, and then just lastly, I will give you one aromatic example like this one. See here, and suppose CH2, CH3. Here, what will be the name of this? So this will be, see on N, there is a ethyl group, N-ethyl benzamide. See benzoyl group, N-ethyl benzamide. Okay. When it is a cyclic structure, then nomenclature is slightly is different. Let's say here CH3, CH2, CH3. So when nitrogen, you have different substituents, you have to name them in alphabetical order. And because of this cyclic structure, now this will be called carboxamide. Carboxamide. Okay. So what will be the name of this one? See, you have ethyl and methyl. So ethyl will come first in alphabetical order. So this will be N-ethyl, N-methyl. You need to tell the N number exactly, okay? So if it is one time, just one N, 2 times, 2N substituents. So N-ethyl, N-methyl, so what is this one? Cyclopentane, carboxamide. Okay, so these are the nomenclature carboxamide when it is a cyclic structure. Okay, any question?